It's day 87 of a strategic patrol beneath the contested waters of the South China Sea, and USS Hampton's crew faces a crisis that no amount of nuclear power can solve. Deep in the submarine's galley, Chief Culinary Specialist Rodriguez stares at dwindling food supplies that were designed to last exactly 90 days. And their mission has just been extended indefinitely due to escalating tensions with a nuclear-capable adversary. Above them, enemy naval forces patrol aggressively, making surface resupply operations impossible without revealing their position and potentially triggering an international incident. This is the hidden vulnerability of America's most sophisticated nuclear submarines. Vessels worth billions of dollars, capable of remaining submerged for months using nuclear power, yet fundamentally limited by something as basic as food storage. When Hampton departed port 12 weeks ago, every available space was packed with supplies. Sailors walked on food, slept on food, and even converted shower facilities into temporary food storage areas. Cans were stacked and covered with cardboard, turning the submarine into a floating grocery warehouse designed to feed 130 sailors for exactly 3 months. The fresh food disappeared within 2 weeks of departure, leaving the crew dependent on canned, dried, and frozen provisions that now occupy every corner of their steel sanctuary. The submarine's reefer and chill box compartments, along with the freeze box storage areas, represent the only barrier between mission success and potential starvation during extended operations in hostile waters where surfacing could prove fatal. Food supply has become the single limiting factor that determines how long nuclear submarines can remain submerged and operational. Unlike the reactor that can run for decades without refueling, or the air recycling systems that can operate indefinitely, food storage follows the unforgiving mathematics of human biology. 130 sailors consuming 3 meals daily with no possibility of resupply while operating beneath enemy waters. Today we're revealing the extraordinary challenges of keeping submarine crews fed during extended operations in hostile territory, the ingenious methods used to receive food while submerged, and why America's most advanced underwater weapons are ultimately constrained by something as fundamental as a well-stocked pantry 400 feet beneath the ocean's surface. The pre-deployment loading process transforms nuclear submarines into floating grocery warehouses where every available space becomes precious real estate for food storage. Submarines carry exactly 90 days' worth of food supplies at full ration, a logistical nightmare that requires stuffing provisions into every conceivable location throughout the vessel. Sailors literally walk on food during the first days at sea, with canned goods stacked in passageways, fresh produce filling storage lockers, and frozen meals packed into every available freezer compartment. The submarine's food storage system operates on a carefully orchestrated hierarchy designed to maximize nutrition while the crew transitions from fresh to preserved foods. The reefer and chill box compartments house fresh fruits, vegetables, dairy products, and bread that will last approximately 2 weeks before spoiling. These refrigerated spaces become the crew's connection to the surface world. Fresh apples, lettuce, milk, and newly baked bread that sailors consume eagerly, knowing these luxuries will soon exist only in memory. Once fresh supplies are exhausted, the crew transitions to frozen provisions stored in the submarine's freeze box compartments. These frozen foods, meats, vegetables, prepared meals, and desserts represent the bulk of nutrition for the remaining 75 days of patrol. Maintaining proper freezer temperatures becomes critical for mission success, as equipment failures could spoil weeks of food supplies and force dangerous decisions about surfacing for emergency resupply in hostile waters. The most creative storage solutions involve canned goods that fill every imaginable space throughout the submarine. Cans are stacked in shower facilities, stored under bunks, packed into equipment lockers, and even secured in areas normally reserved for spare parts. Sailors describe sleeping on cases of canned food, with cardboard covers protecting the containers from condensation and damage during violent submarine maneuvers. The saying, "walked on food, slept on food," becomes literal reality aboard submarines where space constraints force food storage into areas never intended for that purpose. The 90-day limit represents the submarine's ultimate operational constraint, more restrictive than nuclear fuel, which can last for years, or mechanical systems that require only routine maintenance. Food consumption follows the unforgiving mathematics of human biology. 130 sailors consuming 3 meals daily equals approximately 35,000 meals over 90 days, each requiring adequate nutrition to maintain crew performance during demanding underwater operations. This food limitation becomes particularly critical during operations in enemy waters where surface resupply is impossible without revealing the submarine's position. Commanders must constantly balance mission requirements against dwindling food supplies, knowing that extending operations beyond 90 days means implementing rationing procedures that could affect crew morale, physical strength, and operational effectiveness. The world's most advanced submarine technology remains fundamentally limited by humanity's basic need for regular nutrition, making food supply the ultimate determinant of mission duration, regardless of other operational capabilities. When submarines approach their 90-day food limit during extended operations, the Navy employs one of the most dangerous and precisely choreographed operations in maritime warfare: underway replenishment while operating in contested waters. This complex procedure involves surfacing the submarine, abandoning the stealth that keeps it invisible to enemy forces, and coordinating with specialized supply vessels that must navigate hostile seas to reach predetermined rendezvous points without detection. Submarine tenders represent the Navy's mobile lifeline for underwater operations, designed specifically to meet submarines at sea and replenish them with food, fuel, spare parts, and other critical supplies while maintaining operational security. These specialized vessels, essentially floating warehouses equipped with cranes, storage facilities, and precision navigation systems, must coordinate their movements with submerged submarines using encrypted communications that enemy forces continuously attempt to intercept. The actual resupply operation requires the submarine to surface in carefully selected locations where enemy surveillance is minimal, but sea conditions permit safe transfer operations. The submarine's periscope breaks the surface first, scanning for threats before the vessel fully emerges like a steel whale breaching in hostile waters. Once surfaced, the submarine becomes vulnerable to detection by enemy satellites, aircraft, and surface vessels, creating a narrow window of opportunity measured in hours rather than days. Underway replenishment operations involve transferring tons of food supplies from the tender to the submarine, while both vessels maintain headway to avoid becoming stationary targets. Specialized rigging systems developed through decades of naval engineering allow rapid transfer of provisions across the dangerous gap between ships that pitch and roll in ocean swells. Sailors work with military precision to load fresh food, frozen supplies, and canned goods into the submarine's storage compartments, while maintaining watch for enemy forces that could appear at any moment. The PBS NewsHour crew witnessed one such operation involving the USS Pennsylvania, observing the extraordinary risks and precise coordination required to keep submarines fed during extended patrols. The operation demonstrated how food resupply represents a critical vulnerability in submarine operations, a necessary exposure that could compromise stealth and reveal the submarine's position to hostile forces monitoring the area with sophisticated detection equipment. Communication between submarines and supply vessels requires careful balance between operational necessity and security protocols. Too much radio traffic could reveal locations to enemy direction-finding equipment, while insufficient coordination could result in missed rendezvous or dangerous situations where submarines surface in areas compromised by enemy surveillance. These communications often use burst transmissions and frequency hopping techniques to minimize detection risk while ensuring successful supply coordination. Weather conditions add another layer of complexity to food resupply operations, as submarines cannot safely surface during storms or high sea states that would make provision transfer impossible. Enemy waters often present challenging weather patterns that force delays in resupply schedules, potentially extending the time between food deliveries and increasing the risk of supplies running critically low during extended operations in hostile territory. The true test of submarine food supply limitations becomes apparent when large-scale conflict breaks out with a near-peer and nuclear-capable adversary like China, creating scenarios where submarines must operate far beyond their designed 90-day supply limits, while enemy forces actively hunt them throughout contested waters. In these extreme situations, the comfortable predictability of scheduled resupply operations disappears, replaced by a desperate struggle to maintain crew nutrition, while avoiding detection by hostile forces equipped with advanced anti-submarine warfare capabilities. When submarines exceed their 90-day food supply limits during extended combat operations, commanders face brutal decisions about crew survival versus mission effectiveness. The only way to stretch food supplies beyond their planned duration is to implement reduced rationing that affects crew morale, physical strength, and cognitive performance at precisely the moment when peak alertness becomes critical for survival. Sailors accustomed to 3 full meals daily must adapt to smaller portions, fewer hot meals, and the gradual depletion of variety that makes submarine cuisine bearable during extended deployments. Emergency rationing protocols developed by Navy nutritionists attempt to maintain minimum caloric intake while extending food supplies as long as possible, but these measures come with significant risks to crew health and operational effectiveness. Reduced nutrition affects reaction times, decision-making abilities, and physical strength required to operate complex submarine systems during combat situations where mistakes could prove fatal. The psychological impact of food shortages compounds the already extreme stress of operating in enemy waters where detection means death or capture. Historical examples demonstrate the devastating effects of food shortages on submarine operations during extended combat deployments. World War II submarine crews faced similar challenges when missions extended beyond planned durations, with some boats reporting severe crew weight loss, increased illness rates, and declining morale that affected combat effectiveness. Modern submarines face even greater challenges as missions become more complex, and enemy anti-submarine capabilities make resupply operations increasingly dangerous. The strategic implications of submarine food limitations become particularly severe during prolonged conflicts where control of key sea lanes depends on sustained underwater operations. Enemy forces understand these limitations and may deliberately extend conflicts to force American submarines beyond their supply endurance, knowing that food shortages will eventually force surface operations or withdrawal from critical areas. This creates a strategic vulnerability where America's most sophisticated underwater weapons become limited by basic human biology. Submarine commanders operating in enemy waters must constantly calculate remaining food supplies against mission requirements, weather patterns that affect resupply opportunities, and the increasing risks of surface operations as conflicts intensify. These calculations become life or death decisions that balance crew welfare against national security objectives, often requiring commanders to choose between mission completion and crew survival in scenarios where both outcomes carry severe consequences for American maritime dominance. The Navy's recognition that food supply represents the ultimate limitation on submarine operations has sparked revolutionary research into technologies that could extend underwater endurance far beyond current 90-day limits. Advanced vacuum-sealed food preservation systems offer practical solutions for maintaining nutritional rations over dramatically longer deployments, potentially doubling or tripling submarine operational capability without requiring dangerous resupply operations in hostile waters. These next-generation food preservation technologies utilize sophisticated packaging that removes all oxygen and moisture while maintaining nutritional content and palatability for periods extending well beyond traditional canned or frozen storage methods. Laboratory tests demonstrate that vacuum-sealed meals can remain safe and nutritious for years rather than months, offering submarine commanders the possibility of extended operations that match the endurance capabilities of nuclear reactors and advanced life support systems. Perhaps the most ambitious concept under exploration involves developing specialized supply submarines designed specifically for underwater food transfer operations. These vessels would eliminate the vulnerability of surface resupply by conducting all operations while both submarines remain submerged, using advanced docking systems and automated transfer equipment to move provisions between vessels without ever exposing them to enemy detection systems operating on the surface or in the air. The engineering challenges of underwater resupply operations involve developing docking mechanisms that can operate reliably in the high-pressure environment hundreds of feet beneath the surface while maintaining the watertight integrity essential for submarine survival. These systems must account for ocean currents, pressure differentials, and the precise maneuvering required to connect two submarines without compromising the stealth characteristics that keep them invisible to enemy sonar systems. Advanced food storage technologies also focus on maximizing nutritional density while minimizing storage space requirements, allowing submarines to carry significantly more meals within existing compartment limitations. Research into concentrated nutrition bars, dehydrated meals that require minimal water for preparation, and even experimental food production systems that could generate fresh nutrition aboard submarines represent potential breakthroughs that could revolutionize underwater operations. The strategic importance of solving submarine food supply limitations extends far beyond crew comfort to fundamental questions of American naval dominance in contested waters. Future conflicts may require submarine operations lasting 6 months or longer in enemy territory where surface resupply becomes impossible due to advanced anti-submarine warfare capabilities deployed by potential adversaries equipped with satellite surveillance, underwater sensors, and aggressive patrol patterns. Military planners recognize that extending submarine food supply capabilities could provide decisive advantages in prolonged conflicts, where control of underwater domains determines the outcome of broader strategic objectives. Submarines capable of operating indefinitely without resupply would represent a quantum leap in naval warfare capabilities, allowing sustained operations in enemy waters that could reshape the balance of maritime power for decades to come. As we surface from this deep exploration into one of the most fundamental challenges facing modern submarine warfare, the extraordinary paradox of America's underwater fleet becomes undeniably clear. Nuclear submarines, vessels worth billions of dollars and equipped with technology that can operate for decades without major maintenance, remain constrained by something as basic as feeding their crews. These underwater fortresses, capable of diving to crushing depths and remaining submerged for months using inexhaustible nuclear power, are ultimately limited by the simple reality that 130 sailors need 3 meals a day. The 90-day food supply limitation represents more than just a logistical challenge. It defines the absolute boundary of submarine operational effectiveness in ways that nuclear fuel, mechanical systems, or crew endurance never could. While reactors can run for years and life support systems can recycle air and water indefinitely, human biology demands regular nutrition that cannot be manufactured or recycled aboard the submarine. This creates a strategic vulnerability that potential adversaries understand and may exploit during prolonged conflicts where submarine endurance becomes critical to national security. The extraordinary measures required to extend food supplies beyond their design limits, walking on canned goods, sleeping on cases of provisions, converting shower facilities to storage areas, demonstrate the lengths to which submarine crews will go to maximize their operational capability. Yet even these creative solutions cannot overcome the fundamental mathematics of human consumption. 35,000 meals over 90 days for a single submarine crew, each requiring adequate nutrition to maintain the physical and cognitive performance essential for operating the world's most sophisticated underwater weapons. Resupply operations in enemy waters reveal the dangerous balance between operational necessity and tactical vulnerability that defines submarine warfare. The moment a submarine surfaces to receive food supplies, it abandons the stealth that keeps it invisible to hostile forces equipped with advanced detection systems. These brief exposures, measured in hours rather than days, create windows of vulnerability that enemy forces actively seek to exploit through satellite surveillance, patrol aircraft, and surface vessels positioned to detect and attack American submarines during their most vulnerable moments. The future technologies being developed to address these limitations, vacuum-sealed food preservation, underwater resupply systems, and specialized supply submarines, represent potential game changers that could revolutionize naval warfare by eliminating the food constraint that has limited underwater operations since the first submarines dove beneath enemy waters. These innovations could extend submarine endurance from months to potentially years, allowing sustained operations in contested waters that would fundamentally alter the strategic balance of maritime power. The human element of submarine food supply challenges cannot be overlooked in discussions of technology and strategy. Submarine crews volunteer for duty, knowing they will spend months eating preserved foods while living in spaces where fresh provisions disappear within weeks of departure. They accept reduced rations during extended operations, maintain morale despite dietary monotony, and continue performing complex tasks while their bodies adapt to nutritional limitations that would challenge civilian populations. The next time you open your refrigerator and select from abundant fresh food choices, remember the submarine crews operating beneath enemy waters at this very moment, carefully rationing their remaining supplies while conducting missions that protect American interests around the globe. These underwater warriors understand that their operational capability depends not just on nuclear power and advanced weapons, but on something as fundamental as having enough food to sustain their bodies during the months of isolation that define life beneath the waves.